So hello students, hello guys, everyone. In the last session we have seen the electrostatic potential energy, and then we have seen the E versus X curve. In today's class, is going to be the last class of our electrostatic part 1, and after completing the electrostatic part 1 we are going to start our electrostatic part 2. In this part we are going to cover about the dipole, and we will learn each and every concept about the dipole. This will going to be slightly long session. Generally our session is of 1 hour, but slightly it is going to be longer because today we are thinking to complete the electrostatic part 1, and then tomorrow we are going to start the electrostatic part 2. In electrostatic part 2 we will going to cover the Gauss law and the other things, because the conductor and everything, that is going to be very important. And after that we will have one PYQ sessions, and where we will going to solve all the previous year questions of different exams like JEE, mains, advanced, NEET, every exams. Okay, so let us start. So first start with the thing, that is what is dipole. Okay, so what is dipole? What is dipole? See, dipole, I think you have learned in chemistry in 11 class 11th, if you have study, because generally in 11th no one study. So if you have study, so you should know, like, there is something is dipole is there in class 11th. Dipole interaction, induced dipole interaction, dipole induced interaction, something like that, ion dipole interaction. So what is dipole? Dipole are the two charged particles, okay, and they are separated by a very small distance. The distance is very small. So what is dipole? The charged particle, charged particle separated by a small distance. But the thing is that this charged particle should be equal in magnitude and opposite in direction. Should be equal in magnitude. Basically, you try to understand that it is a quantity, okay, magnitude, and opposite in direction. Not direction, sorry, opposite in sign, okay, not direction. Charge don't have a direction. Charge is a scalar quantity. Opposite in sign. For example, this is my plus q, and this is my minus q, and the distance between them is r, or you can say, better to be say as, distance is d. Correct? This is my plus q, this is minus q, and the distance between them is d. So what is my dipole? For this we define something called as a, this is a dipole, this is something called as a, this thing is called as a dipole. This is a dipole, and for this we have a dipole moment. Dipole moment that is denoted by p vector. Okay, and it is a vector quantity, and the value is defined as, what is the magnitude? The magnitude is defined as q, take the charge and the distance between them. But it is a vector quantity, so its direction will be, what is the direction? The direction is from negative to positive charge. That is the direction. So if I ask you the direction will be from this, from negative to positive. Correct? Correct? Any doubt? So this is what we define as a dipole moment. So let us take one example. Suppose this is my x-axis, sorry, y-axis, and this is my x-axis. My x-axis. Suppose this charge is 2q, and this charge is minus q, and this charge is minus q. The distance is a, this distance is also a. Find E net. Since you have to find the net dipole moment, I need the magnitude only. Okay, I need the magnitude. So how to solve? Very simple question. I don't want to even solve it. Just please solve it and tell me what is the net dipole moment. What is the net dipole moment? What you will do? What you will do? Just break this charge into two charge, na? Break this charge into the two charges. This will become plus q. This will become plus q. So there will be one dipole moment in this direction. There will be one dipole moment in this direction, negative to positive. So this is like this. This is like this. So you will get net in this direction. What is the value? That will be root 2 into a. That is root 2. P is defined as 2 into a. Correct? Simple. Clear? Any doubt? Okay. So let us do some good question. Okay. Let us take some good example. Suppose suppose let us take a hemisphere. Correct? Let us take a hemisphere and suppose the charge on this hemisphere is q. Radius is r, obviously, and suppose at the center I have another charge minus q. I have another charge minus q. You have to find the dipole moment. You have to find the dipole moment. First of all, you tell me whether it can make a dipole or not. It is a ring. It is a ring basically. First, you tell me whether it can make a dipole or not. Yes, it can make. Just tell me what will be the net dipole moment. Okay. How to solve it? Just think about it for a 1 minute. Think it and try to solve it. How to solve? 1, 2, 3. Okay. See. First, what you have to do? First, for how to take a small element on the ring, let's take alpha, some d alpha, because, and what is this value? Their charge will be dq. Okay. Lambda is not given, total q is given, so it will be q by, on total charge, total angle pi, we have a charge q. Okay, correct? On total angle pi, we have a charge q. So on on angle alpha, what is the total charge? Pi by alpha, correct? So on angle small d alpha, what is the charge? Q by pi into d alpha. So what is the charge? Q by pi into d alpha, correct? So let us take it. It will be dq will be this, and this will be minus q. So what is the direction of dipole moment? Minus to plus, correct? So there will be two component you will get. Basically the direction will be how much? The direction. So if you see the direction, let me draw the direction for you. If you see the direction, this is the case. Try to see, this is the case. Basically basically you are getting the like minus to plus. Okay, minus to plus. This is my p. So this angle is alpha. So here you will get p cos alpha. Here you will get p sin alpha. This angle is alpha. P cos alpha and p sin alpha. That is a, or you can say it is a small dipole moment, na? dp. Correct? Any doubt? Okay. If I take the component here, then you will get again a p cos alpha here. Again you will get one more p sin alpha here and p cos alpha here. So obviously this p cos alpha will get cancel out. Cancel out because of the symmetry, correct? This cancel out. So obviously what we will get? We will get only the p sine alpha. So let us integrate dp sine alpha. What is dp? Dp is q. What is the q? Q is what is the q? What is that q? Q is how much? Q by pi into d alpha into sine alpha integration. What is the integration of alpha? Alpha integration is from 0 to pi. This value will be 2 by pi. Sine alpha integration is minus cos alpha. Cos pi is minus 1, cos 0 1 1, that is 2 q by pi. Correct? 2q by answer. Clear? So what is my p net? That is 2q by pi. If suppose it is a hemisphere, then what is the value I will get? I will get 4q by pi. Simple. The answer will be 4q by pi. And now this in hemisphere, this component will not become 0. Here we get p cos alpha is equal to 0. This will be cancelled out, because if we take the component here, the p cos alpha will automatically cancel out. But here we will not get 0. In case of hemisphere, if it is a hemisphere, you will not get 0. Clear? This is one example. I hope you get a confidence how to calculate the dipole moment. Okay? Okay, clear? Till now it is clear here. Please take a look. Till now it is clear. Shall I proceed further? Okay. Now next thing is that electric field due to the dipole. What is electric field due to the dipole? Okay, I am not going to calculate this thing. Here we have a two cases. Okay. This you have to only do. First is axial case. Axial case. In axial case means axial case. What do you mean by axial case? Suppose there is a dipole is there. This is minus q. This is plus q. The small distance is d. So I have a dipole moment of q into d. And suppose I at distance r from this dipole, r, or you can say distance r, or it is better to say at this point, suppose this distance is L, you have to find here, I want to know the what is electric field. Okay, what is electric field here? This I am not going to calculate. It is a very simple, you have to find the electric field. You know how to do. What is if this distance is L from the center, what is the distance from this charge? Q1. The distance will be L plus d by 2. Correct? And what is this distance? L minus d by 2. Correct? So what is my E net? My E net will be, due to this charge, the electric field will be in this direction, and due to this charge, the electric field will be in this direction. So E net will be E1 minus 2. That is K Q upon d minus L by 2. Sorry. L minus d by 2 whole square minus K Q upon d by 2 plus L whole square. So what you will get? KQ into, that is d square plus L square plus 2 plus DL minus d square minus L square. So this will become almost 2d into L. Correct? It will become 2d into L. If you open that, become 2d L divided by how much? L square d square by 4 ka whole square. Okay, clear? Till now here it is clear, and we know the L is very much greater than D. So we can say my E net will be how much? See, Q into D is how much? P, Kp, L upon, I can neglect this d by 4, so this will become how much? Capital L, and this will become L to the power 4. This L will cancel out. You will get K P by L cube. 2 will be also here. 2 Kp by L cube. This is my E. And what is the direction? The direction is 2 Kp by, so it is along the p vector, means the direction is along the p vector. So in axial case, what is the dipole, what is the electric field due to the dipole? It is 2 kp by l cube. Clear? Okay. Similarly, we have another case. Another case. What is the another case? That is case 2. That is equatorial. Equatorial case. We will provide you this note, okay? And once the chapter will be finished, you will get the notes in the last video. Okay. So this, when this video will be uploaded, we will have this notes. Equatorial. In equatorial case means, suppose this is my minus q, this is my plus q, and this this distance is suppose d, and from perpendicular distance L, I want to calculate the electric field at this point. So how to calculate? Very simple. Due to this charge, the electric field will be this direction, correct? Due to this charge, the electric field will be in this direction, correct? Now you tell me, this angle is theta, this angle is also theta, and this angle is also theta, this angle is also theta. So you will get my E net is equal to how much? That is 2E cos theta, correct? Because E cos theta, E sin theta, E cos theta, E sin theta, sin theta will cancel out, so you will get 2E cos theta. Now E is how much? What is the electric field? That is, electric field will be K Q by R square. What is this distance? You tell me what is this? This is d by 2 L, so this will be under root of d by 2 by square plus L square, a whole square. Okay. Then cos theta is how much? What is cos theta? This is theta, so this cos theta will be d by 2 into this thing, because b by h. So this will be d by 2, sorry, minute. Yeah, d by 2 into this thing, that is d by 2 is a whole square plus, remember this is d by 2 whole square plus L square power 1 by 2. So from here you will get my E net is equal to how much? This 2 will cancel out. Q into D is dipole moment, so you will get K P vector, and you know that is my D is very less than L, so this will become how much? L, how much? See, this is power 3 by 2, so L square will be neglected here, sorry. Okay, so this will become power 3 by 2, you will get L cube here, so this is equal to our E net. But one more thing, E net, why there is why I have put the minus sign here? Because if you see, my dipole moment direction is this direction, and the net vector electric field net is in this direction, so that's why I am putting here the minus sign. So my direction is opposite to dipole moment. Opposite direction is opposite to dipole moment. Clear? So my E net is opposite to the direction of dipole moment, that is Kp by, and if you see the distance is same, then my equatorial electric field is just half of the axial electric field. So that is a one more thing, correct? Okay, so this is our net electric field. Now just let's take the general case. Okay, let's take the general case. That is general, means it can be axial also and it can be equatorial also. Let us how to, okay, let us take like this. Suppose this is some point and this distance is r, this angle is theta, okay, and this is my dipole moment, that is p, and I have to write the electric field at this point. Okay, how to write electric field at this point? Simple. Here we have a P na. This can be broken into the two component. One is P cos theta and one is P sin theta. So we have a two component. One is, that is P cos theta, and similarly we will have another one is P sin theta. If you see, this P cos theta is along the, it is axial for this point, correct or not? It is axial. So what is the electric field for this P cos theta? So here the electric field will be E1 for this, because it is axial for this na. So here the electric field will be, that is 2k P cos theta divided by R cube, correct? But for this one, for this point, this dipole moment is equatorial position because it is perpendicular. So here the electric field will be, so for one direction is this. Okay, let me first bring it down little. Okay, so to do this dipole moment, the direction is this because it is axial. For this dipole moment, it is perpendicular, so the direction will be opposite to the dipole moment. So here you will get the direction like this. And what is the value? The value will be k P sin theta by R cube. So what is net vector? The net vector is something like this at some angle alpha. Can you find that alpha? Yeah, that tan alpha will be is equal to tan theta by 2. What is E net? My E net will be this plus this, correct? This two, sum of these two. So this will be under root of, because they are perpendicular to each other. If you add this thing and do the under square and everything, what is the value you will get? You will get k P by R cube root over of 1 plus 4 cos square theta. That is a general case. That is a general case. Why? For axial, let us check it. For axial, the theta is equal to how much? 0 degree. For axial case, see here. For axial case, the theta is how much? Because the point dipole it come like this, the theta will be 0 degree. So for this case, theta is 0 degree. Theta is 0 degree. So what is my E net? E net you will get how much? If you keep theta equal to 0 degree, this will become 2. You will get 2 kp by R cube. Similarly for equatorial case, theta is 90 degree. So my E net will be how much? Kp by R cube. Clear? I hope you are clear how to calculate the electric field to do the dipole. Any doubt? Please note it down. Completed? Okay. Now before going to the potential due to the dipole, we have to first understand what is electrostatic potential. See, we have seen what is potential, electrostatic potential energy. Now potential is also the same thing. Potential is exactly the same thing, and I will explain you the potential in just not more than 3 lines. That is sufficient to understand the electrostatic potential. Okay, let us see this. Let us give our next heading. Then we will move to the potential due to a dipole. Okay. Okay, that is electrostatic potential. What is electrostatic potential? Let us see and understand this. Electrostatic potential, basically how we define the electrostatic potential. Let us understand just in detail. Okay. Okay, understand it. See, suppose everything, whatever the conditions we have assumed in while defining the electrostatic potential energy, that there should be no change in kinetic energy, everything is same. What is how we define the potential? We define that delta V, that is change in potential, is equal to V final minus V initial is equal to work done by external agent for bringing the charge from final to initial point divided by the same charge, or you can say test charge. Okay, let me general, that is the thing. Now you tell me, what is the work done by the external agent? That is equal to the minus times of the work done by the electrostatic force, correct? And for describing this thing, we have to consider V initial is equal to 0 for infinity, obviously. Then we will define my V final is equal to, or you can say potential at a point. This is a potential at a point, and this value is defined as how much? That is K Q by R. If you put everything, this value, and you will do this everything, there will be some derivation will be there. I am not going for the derivation, I am directly going for this point, because this derivation is not required for here now, because if you understand the potential energy, everything is same for the potential. For doing that derivation, you will get KQ by R. For this, what is the conclusion you have to understand? Conclusion, what you have to understand, you have to put here with sign, this sign. What is the conclusion? The conclusion is very simple. It is very simple. See, if there is a charge Q is there and the distance is R, then at this point, what is the potential? The potential is V, which is given by KQ by R. Simple as it is. That is only the conclusion we have. And it is a what type of quantity it is? It is a scalar quantity. It is a scalar quantity. Okay. So for positive charge, it will be positive, and for negative charge, it will be negative. Okay. For positive charge, it is positive. For negative charge, it is negative. So if I ask you now, whatever the questions we have solved in electrostatic potential energy, the same question we can solve by using that electric potential also. How? Let us see one example. You will understand what I am trying to say. For example, if you remember, we have solved one question there. That is this question. There is charge Q, there is charge Q, there is a charge Q, there is another charge Q. Find the potential at this point. What is potential at this point? What you will do? Potential at V1 plus V2 plus V3, that is V4, simple, because it is a scalar quantity. So it is side is A, it is square, so K Q by root 2 A by 2, correct, plus K Q by root 2 A by 2, like that, plus K Q by root 2 A by 2 plus K Q by root 2 A by, simple. This is my potential energy. You will get how much? 8 K Q by, simple, answer, simple. But how the potential make the things easier? Let us understand. If in this same question, if I ask you, if I change this question slightly, in the same question, I change it slightly, what I am going to do? Let us see. The same question. Example 2. Suppose initially this system is here, and now I have, what I have did, I have bring a, this is my initial system, okay, this is my initial system. Now what I have did, let us see here. Sorry. Sorry. So what is now I have did? I have did one change. What is the change I have did? Just see. This is my initial system. Now I have bring a, what I did, I just from, this is my system 1, and this is my system 2. So from this system I am going to this system. Okay, from this system I am going to this system. I ask you, what is the work done in this process? In this process by external agent, because external agent will do the some work na, to make this system, obviously. So what is the that work done? How to calculate? How to calculate this work done? Simple. So how to calculate that work done? First, if you calculate the potential energy of this system and potential energy of this system, and you take the difference, that is going to be the change, because the change in potential energy, U final minus U initial, that is equal to minus times of work done by the electrostatic force. Correct? So what is my work done by the external agent? The work done by the external agent is equal to minus times of work done by the electrostatic force. That will be equal to U final minus U initial. That is a simple thing you have to apply, and for that reason I am giving you it as a homework. So what you have to do, simply you have to simply find the potential energy of this system. First you have to find the potential energy of this system, then you have to find the potential energy of this system, and then you have to simply subtract this and you will get the work done by the external agent. Simple. Clear? That is the thing. So what we have understand? We have understand what is electric potential, and we have seen some example. Now, as you understand what is electric potential, it is nothing. It is similar to that of potential energy, and it is defined for a point charge. For a point charge having a charge q at a distance r, the potential is defined as kq by r. It is a scalar quantity, and it is scalar quantity, and it is defined for a point charge, that is kq by r. If suppose I have a ring, if suppose, let's take one example. Potential on the axis of a ring. Suppose this is my ring and this is my center. From the center at distance x, it is charged to q. I want to calculate what is the potential at this point. It is a scalar quantity, simple. Can we directly apply the formula here, kq by r? No, because it is not a point charge. So what you will do, from here you will go to some angle theta, to d theta, and you will take some element dq. That dq will be equal to how much? Lambda, that is lambda into what is that, dx. This is small is dx. And what you will write? You will write the potential k, q is lambda dx. What is the distance? That is, suppose r. What is the distance? R square plus x square to the power 1 by 2. That is a small potential dv. To get the total potential, what you have to do? You have to integrate, correct? When you integrate k lambda into dx upon r square plus x square to the power 1 by 2. So x is constant or variable? X is a constant or variable? Dx is what? It is a constant or variable? It is also a constant. When you integrate, what is the limit of x? X will go from 0 to 2 pi into capital R, correct? Just you integrate it, you will get k lambda into 2 pi capital R divided by x square plus r square to the power 1 by 2, correct? This will become k q by root over of r square plus. So the electric potential due to the ring on its axis is defined at kq by under root of r square plus x square. Simple. Clear? So there is a one example, one previous year question on this only. What is the question? Let us see. So suppose there is a one ring here, there is another ring Okay, these are the two rings. Okay, suppose the charge on this ring is plus q, charge on this ring is minus q. Okay, in this case only, if I ask you what is the potential at center, V at center will be kq by r, because you have to put x is equal to 0 for center, kq by r. Now come to this question. What they have asked, suppose this has a plus charge plus q, this has a charge minus q, and the radius is r. For this also the radius is r. Charge, there is a charge q naught is here. It has been moved from this point to this point, from this center to this center. It has been moved from here to here. Means this charge has been moved from q naught, from this point to this point. So find the work done by external agent. External agent. Now here we have learned the potential that will be useful. We know that is V delta V is equal to what is work done by external agent divided by Q, correct? Here we have Q naught, so that is a Q naught. This is a previous year question. Okay, so from here we can write my work done by external agent is equal to Q naught into V final minus V initial. Suppose this is my A and this is my B. So potential at B, potential at B minus potential at A. Now what is the potential at B? First, my first aim is to find the potential at B. So see, there will be potential due to this due to this ring at its center. What is that potential? K Q by, it is minus charge, so minus K Q by R. Plus there is a potential due to this charge at it, because it is an axis point, and suppose this, and this distance is also given, I haven't mentioned, this is 2r. This distance is 2r. So for simplicity, let us take it, for simplicity let's take it as r. Okay, this will be access points for this ring, so it will become k q by root 2r, correct? Okay, minus, now potential at A means here potential, so it is a center of this also, so this will be k q by r. Then due to this ring it will be access point, so this will be my plus, because my minus will be there, so and minus q, so it will become plus k q by root 2r. So this quantity will added and this quantity will be added. So what is my work done? The work done by external agent will be equal to how much? That is q naught into, if you add this thing you will get how much? Root 2 times of kq by r minus 2 times of kq by r, correct? So you, what you will get, you will take root 2 common, you will get kq by r, yeah, q naught minus root 2 into k q naught by r. So what is the value you will get? You will get k q naught by r to root 2 minus 2. That is the answer. That is the work done by the external agent, correct? Any doubt? So this is the examples, clear? So we have seen the potential, we have seen what is the potential due to the ring on its axis and on its center also. Now the next thing is that next thing is relation between E and V. Relation between E and V. That is, what is the relation between electrostatic potential and the electric field? So there is a relation. The relation is given as E is equal to minus, the relation is defined as relation is defined as E is equal to minus dV by dr. E vector is equal to minus dV by dr. Okay. So for example, if I ask you what is my potential, so dV is equal to, I can write minus E dot dr. That is the two important relations which you have to remember this. Suppose, so what type of question they will ask you on this? Suppose, let us take example. Suppose they given potential is equal to somewhere 2x I cap plus 3y j cap, and they ask you to calculate electric field. What is electric field at 2 comma 1 comma 3? So how to solve this solution? Okay, how to solve this? How to find the electric field? See, we know electric field is what? Electric field is minus dV by dr. So I will put the value d into what is the potential? 2x into I cap. Sorry, I did one mistake. Very blunder. Sorry. How the potential is a scalar quantity, na? So how it can be vector? You are not also telling me. Suppose this is 2x plus 3y. This is 2x plus 3x plus 3y divided by dr. So how we can differentiate with respect to x and y, both are there. So basically if you expand this formula, then you can say there my E vector is equal to, it is written like this, minus d, not d exactly, is del v by del x I cap minus del v by del y j cap minus del v by del z cap. That is the exact formula. Means when partial differentiation with x while keeping y and z constant. Similarly, differentiation with respect to y while keeping other constant. Similarly, partial differentiation with respect to z while keeping other constant. So if you apply this thing here, can you tell me now what is my electric field? Yes, it will be partially differentiate this, so it will become 2 I cap. This will become plus 3 j cap. And if it asks at this point, so at this point you will get minus 2 I cap minus 3 j cap Newton per coulomb. Now suppose another example, they will give you in spite of this, suppose they will give you electric field, suppose they give you 2x I cap plus 3y j cap, and they ask you potential difference simply between the 2 points 1 comma 1 comma 0 and 0 comma 1 comma 0. What is the potential difference between these two? Okay, potential difference. How to solve this? Then here you have to find potential difference now, so you will apply this formula. So let us apply here. Okay, let us apply here the integration, that is equal to minus 2x I cap 3y j cap. Now here we have a dr. Dr is going to be written as, remember, dx I cap. When you open the dr, it will be dx I cap, dy j cap, and dz k cap. That is the exact formula of dr. So when you open this and you do the dot product, so I will be multiplied by I, y will be multiplied by y, and z will be multiplied with z. So what you will get, minus sign you take out, and you will get 2x dx, and what is the x limit? From 1 to 0. Okay, similarly here 3y dy. What is the y limit? See, 1 to 1. Similarly last dz, it will be 0. So now you integrate this, and what is the value you will get? See, this will become x square by 2, 2 will cancel out, 0, upper limit 0 minus 1, so you will get minus 1 here, plus, but here the limits are same, so that this integration will become 0. So what is the final value you will get? You will get 1 volt. So the potential difference is 1 volt. So this type of question you will get in your exam. Mainly when I teach you conductor, there I will again go to the electric potential, and I will discuss more on the electric potential. Here I am giving you just as a view how the electric potential, but in detail we will go into the electrostatic part 2, where we will discuss the electric potential in very much detail. Okay, so just now you get a one picture and how to solve the questions. Clear? I hope till here you don't have any doubt. Please note it down. Completed? Okay. So now we can move to the next point. Remember that we will again go to the potential in electrostatic part 2. Okay, so now here let's start with the another thing, that is potential due to the dipole. Potential due to dipole. That is a very small topic. And what is this? Now you can tell me how to calculate the potential due to dipole. It's very simple. So first case, again there will be two cases. First case is same axial case. What is the axial case? Simple. Suppose I have a plus charge q is there, minus charge q is there. The distance is d. Now from center, suppose the distance is L, and here I want to calculate the potential V. Okay. How to calculate? So this distance will be how much? L minus d by 2. And what is this distance? This distance will be how much? L plus d by 2. So what is potential? V net. That will be V1 minus V2. V1 is kq by how much? Kq by how much? L minus d by 2. Correct? Sorry, L plus d by 2 na? Minus kq by L minus d by 2. Correct? So this value will be how much? Because why V1 minus V1 plus V2 na? Not V1. And this one is negative because the charge is negative. So when you do this, you will get kq. This thing is L minus d by 2, and L plus d by 2, you will get minus d by 2. Saying correct or wrong? Minus L will cancel out. Minus d, you are getting minus d, not minus d by 2. You will get minus d. Correct? Divided by L square minus d square by. Correct? Now we know L is very less than d. So from here we can say my potential V net is equal to how much? It is minus k into p divided by L square. Correct? That is my potential due to the dipole. Clear? Any doubt? So that is a for axial case. Now similarly, let's come to the equatorial case. Case 2. For equatorial case. So for equatorial case, if you see, suppose this is my plus q, this is my minus q, this distance is d, and equatorial means suppose this length is L, and here I want to calculate the potential. So we join this. What is this distance? This distance will be L square plus d by 2 whole square. Correct? Similarly here also, and it is a vector quantity, so V net is equal to V1 plus V2. Correct? What is V1? kq by this distance. What is this distance? Root over of L square plus d by 2 whole square minus kq by root over of L square plus d by 2 of whole square. So you will get 0. So in equatorial, and that is a very important result, in equatorial position. So in equatorial position, V net is equal to 0. And in coming chapter, electrostatic part 2, we will see that this is called as a equipotential surface. Okay, that we will discuss later. Okay. Clear till now? Clear? Okay. So this is the uh, two cases. Now the next thing is the general case. Yeah, next thing is we have general case. So let us take a general case for potential calculation. Suppose I have I have potential P here, okay, and suppose this is some point at angle theta, okay. So what I will do, what is my approach to solve this? That I told, we will take two component. One component is act as equatorial, that is P. This is P cos theta and this is P sin theta, correct? That is P cos theta. And suppose this distance is r. So what is the potential due to this? We will get P cos theta into K divided by r, correct? Don't take minus sign here. There we are getting minus now because that is that case. But here we will not get minus. That will be defined by theta only. Theta will manage everything. And this value is P sin theta. Due to P sin theta, the potential will be 0. So what is my V net? My V net will be K P cos theta divided by, what is the value? R square or R cube? Let me check once. It is it is R square. This is R square, correct? So this is called as a potential due to a dipole, a general case, general formula. So if I ask you one example, take one example. Suppose I have a potential P here, or okay, let us take one example. Suppose there is a potential P is there, okay, from position B. This is my position B. This angle is suppose 30. This angle is suppose 30 degree, and the position A, and suppose this angle is 60 degree, and suppose the dipole moment is P, okay. From find work done by external agent from point B to A. How to solve this? How to find the work done by the external agent in moving a point from B to A? How to find? Okay, this length is 1 meter, this length is 3 meter, correct? Now you tell me. See, what is the work done by external agent? That is equal to, what is the work done by the external agent? That is Q naught into from, we are going from B to A, na? So VA minus VB, correct? A charge Q naught. Here we have to write charge Q naught. So this is potential at B, A. What is potential at A? If the dipole is initially at this position, now it is at here. So what is the potential at A? It will be Kp into cos 60 or cos 180 minus 60. Cos 180 minus 30, because we are taking from horizontal. 180 minus 60 divided by 3 square, that is 9, minus, correct? What is K P into cos 30 degree divided by 1 square, that is the answer. Now you calculate this. What is the value? Whatever value you are getting, that is the answer. Clear? Any doubt till here? If you have any doubt, please see it, and if anyone have the doubt, please tell me. Please tell me, anyone have a doubt? If any doubt is there? Any doubt? So that is the dipole moment due to uh, a dipole, and how to solve the different examples on the dipole. Clear? Any doubt? Okay. So we left with a very one small topic, that is dipole in an electric field, uniform electric field and non-uniform electric field. So that thing we will discuss tomorrow in tomorrow's class, and then we will start our next chapter, that is a electrostatic part 2. Clear? So till now, I hope you enjoyed this session, and take care. Goodbye, and please like it, subscribe it, and share it, and have a nice day. Thank you.